Element 42 on the periodic table of elements is molybdenum. This is Norris Teaches Science. With me, Mr. Norris. Today on this physical science edition of the video, we're still in the physics section of physical science, or we are in the physics section if this is the first video you are watching. We're going to do energy calculations. So by the end of the video, I can discuss the difference between kinetic energy and potential energy, including how to solve for each. What is kinetic energy? Kinetic energy is the energy of motion. If something is moving, it is kinetic energy. And kinetic energy depends on the mass and the speed of the object. We measure it in joules, and the symbol for kinetic energy is going to be Ke. Potential energy is the energy that is stored or for energy not moving. Is based off the position of the object and the height of the object. Potential energy is also in joules because all energies have the unit of joules, and the symbol here is PE. So let's look at these four situations, figure out if it's kinetic energy they're talking about or if it's potential energy. This first one, number one, says rock sitting on the cliff's edge. Well, it's not moving. That's the big thing. Is it moving? Is it not moving? It's just sitting there. So this is potential energy. A car going down a hill. Is it moving? Yes. Since it's moving, it's kinetic energy. Sitting at the top of a slide. Are you moving? No. You're just sitting there. So that's potential energy. Now, going down the slide, you're moving. So that's kinetic energy. All right, let's calculate kinetic energy. Here's the formula for kinetic energy. Ke equals 1/2 m times v squared, which translates to kinetic energy equals 1/2 times the mass times the velocity squared. Ke stands for kinetic energy, which unit will be joules. M is mass, its unit is going to be kilograms, and v is for the velocity, and it's going to be its unit is m over s. All right, so we have this example over here. When you know you're doing a kinetic energy question, you're going to write out Ke equals, you're going to write out M equals, and you're going to write out V equals. So you can identify everything. There is no triangle for this type of equation. You are going to have to solve it algebraically. And I know I just used the word algebra. I'm sorry. It just has to be done. It says the cart on a roller coaster has a mass of 100 kilograms and is going at a speed of 6 meters per second along the track. How much kinetic energy does it have? So what are we trying to find? We're trying to find kinetic energy. So since we're trying to find kinetic energy, that's the question mark. M is the mass. The mass up here is 100 kilograms. And V is velocity, and it is 6. Now we're going to take these and plug them into the formula. Ke stays because we're trying to find it. Equals 1/2 times, what's the mass? 100. And then we're going to multiply that by 6, the velocity, but we're going to have to square it first. So we have to take these step by step, little by little. You cannot just plug this straight into the calculator because you will not get the right answer. All right, so we're going to bring down the 1/2 times 100, because the first thing we're going to have to do is use our calculator and do 6 squared. If you do 6 squared, you would know that that is 36. All right, now here's the next thing you have to do. I always work backwards. I would save the 1/2 for last. I'm going to do 100 times 36. So 1/2 times, if you multiply those, you get 3,600. Now we have 1/2 times 3,600, or in sense, 3,600 divided by 2. If you do that, you get 1,800 as your answer, and then you add the joules, and that's how much kinetic energy it has. All right. The other type of calculation is calculating potential energy. Here's the formula for potential energy. It reads potential energy is equal to the mass times the gravity times the height. PE is potential energy with the unit of joules. M is the mass, it's in kilograms. G is gravity, as it's on Earth. If you don't remember, gravity on Earth is 9.88 meters per second squared. If you don't know about gravity, go check out the video on gravity and weight because it will help you out with that. And H is height, and its unit is going to be meters. So just like a kinetic energy equation, you're going to list out all these terms: PE equals M equals G equals H equals. All right, let's read the thing. It says 30-kilogram rock is sitting on ledge 5 meters from the ground of Earth. How much potential energy does it have? So what are you trying to find? You're trying to find potential energy. So go ahead and leave a question mark there. M is the mass. Its unit is kilograms, so that's 30. G is gravity. What planet are we on? Earth. If it doesn't say what planet, just assume Earth. If you're not wanting to use 9.8 for gravity, the question would give you a new gravity. And height is in meters, and that is 5. So we're going to do potential energy equals 30 times 9.8 times 5. And this one, you can just plug this straight in the calculator. It's going to give you the answer. You don't have to do it step by step because we don't have that square and we don't have that half. It's just all multiplication numbers. And when you do that, you get 1,470 joules. And that's how much potential energy this rock has. Now, potential energy is a little special. So we have potential energy equals mass times gravity times height. But we also have the weight formula. If you don't remember, weight, F of G, equals mass times gravity. Well, mass times gravity is also in the potential energy formula. So you could write the potential energy formula as potential energy equals weight times height, as long as your weight is in newtons. And this is a little bit about energy calculations. I hope you learned something today. Come back for another video. I think the next video I'm going to do for physical science is energy conversions. All right, this is Miss Norris. I'm out for today.